And we're off. So this is a recording for my 30S applied students. This is the second part of lesson 4.3. And as I was just saying to the class a moment ago, I'll go fairly quick here because we've done this as an activity where I made you actually draw these things to scale and we measured them and everything. You'll even notice some of the numbers are similar. We do like this 30-degree angle for reasons that you'll see in a minute. All right, so the ambiguous case of the sine law. Sounds like a Nancy Drew novel. Nancy Drew and the ambiguous case of the sine law. When you are asked to solve a triangle that is side-side angle, you know I'm going to call that angle side-side. They're being cowards here. You must consider the ambiguous case of the sine law before starting. Determine if there is 1, 2, or 0 triangles possible, then solve the triangle. For each triangle, data are given. Data is given? Data is given. Terrible, terrible grammar. Determine the number of solutions. No solution, 1 solution, or 2. Then solve the triangle for all missing data. Okay, we're not going to break out rulers again, but we are going to try our best to make things somewhat proportional to what they'd be in real life. So I'm going to start by drawing myself what they've given me. Okay, I'm going to have to rotate the screen. Now I'm stuck on cords. Hold on. There we go. Okay, so I'm going to start by drawing a 30-degree angle in a lovely purple color. I don't know why I'm on purple, but there we go. 30 degrees. Now, it tells me that side B, which is right next to angle A, if this is angle A, side B is one of these two lines. I'll put it up. I'll make it the up line. It doesn't really matter whether you go up or down, but I'll make it up here. Now, if that side's 6, I honestly have no idea how long the bottom side is. I know the other side is 2, and I kind of suspect already, if this line from here to here is 6, 2 is like a third of that line. Is a third of this line going to make it down to the bottom? I really highly doubt it. But how do I prove it? Well, I prove it like this. If this line just made it to the bottom, it would be a height in a right triangle. And if it was a height in a right triangle, we could use SOHCAHTOA, because the sine of 30 would be opposite this h over the b side, which is 6, which is the hypotenuse. So, by rearranging this using my cross-multiply skills, h is equal to sine 30 times b. And in this case, b is 6. So if this height is longer than 2, this doesn't make a triangle because the A line's not long enough to make it to the base. And it's not, and I can tell again, why do we like the sine of 30? Why do we like 30 degrees so much? Because the sine of 30 is exactly a half. It's a nice, easy sine number to work with. So if the sine of 30 is a half, feel free to punch this in your calculator if you don't believe me. But if the sine of 30 is a half, what's a half of 6? 3. Therefore, I'm going to go back to, black here. Therefore, no triangle is possible. And the reason for that is because the given side A, which is opposite the given angle, is less than a height would be. And height would mean that that's the shortest possible side you could have and still make a triangle, because it just makes it to the bottom. A is not long enough to just make it to the bottom. 2 is shorter than 3. Now, don't get lulled into the sense of security that anytime we give you one of these problems, it'll be a 30-degree angle. It might not be. And if it's not 30 degrees, it won't be exactly half. I'm going to just make one up, just off the off the top of my head. What if instead of 30 degrees, A was 40 degrees? And what if the B, we'll keep B the same at 6. What if the A side was 3, let's go with 4. What if A was 4? Is 4 big enough to make it to the bottom? You think it might be? How do we prove it? Again, pretend it was a height. Height is equal to b times the sine of a, or in this case, 6 times the sine of 40. If this number here is bigger than 4, then 4 is not enough. So let's see. Is it bigger than 4? No? Okay, I'm going to punch buttons with you and see. Okay, well, I got to get out of this graph that I was doing with my other class. So 6 times the sine of 40, 3.8. So it would make it. 3.5 wouldn't have been long enough, but 3.8 is. And notice 3.8 is not half of 6. It's quite a bit more. Okay? So therefore, yep, this would make a triangle. In fact, it would make 2 triangles. We're going to see that in a minute. Okay, so the first solution here is there's no triangles. Too small. This is like Goldilocks and the 3 Bears. This one's too small. You need a calculator? Just here, borrow this guy. There you go. We got a question at the back. Because the given side here is shorter than a perpendicular height would have been. And the perpendicular height is the absolute shortest line you can get that would close this purple triangle up and make you a triangle. That's right. So the height is, assuming that the letters we're using are A, B, and C, and A is the given angle, it's B times sine of A. And think about why that is, right? Because opposite and hypotenuse. Right. All right, so that's kind of my test to see if I have a triangle at all. If A is less than H, then there's no triangle. Okay, this A is definitely not going to be less than H. We already can see that. It's quite a bit more. In fact, it's longer than B. So if I sketch that, if I put a 30-degree angle here, if side B is 6, and side A is longer than 6, there is only one way this triangle can go. Because this side 8, that's opposite angle A, is longer, boy did I ever exaggerate that, is longer than 6. Okay, so, all right, hang on. The question I've got is, couldn't you go the other way? So you want to take this line here that's 8 units long and go that way?
Or straight.
And you want to go, okay, you want to go this way? Yeah. It's longer than the 6. It's not going to stop at this bottom line. And you're thinking, well, then make the 30 bigger. You can't make the 30 bigger. We're given 30 degrees. We're stuck with it. So there is only one way this triangle can go. Okay. And then from there, does it say we're supposed to solve these? Yes. So we're supposed to solve these triangles now. So the first one I couldn't solve. It wasn't a triangle. There's nothing to solve. But this one I can do some solving now. So let's see, what am I missing? Let me put the missing stuff. I'm kind of digging that purple now. Let's say that if this is side B, this must be angle B. And if this is angle B, then that makes that angle C. And that makes this little side C. So what would we like to solve first? We actually only have one choice. We have to solve angle B because that's the only thing where we know an opposite side. So sine of angle B over B is going to equal sine of angle A over A. And this is the part that's just like chapter 3. So we should be fairly good at this, so I'll skip some steps here. I will just jump right to plugging the numbers in and doing the cross multiply. So the B moves up 6 times the sine of 30 over, and what's the bottom? A was 8. Okay, so feel free to punch that. And again, I'll skip a step. I'll just go right to angle B. And here I'll just bring the calculator up and punch buttons. So 6 times sine 30, close bracket, divided by 8 equals, and then I will inverse sine that. Oh no, I don't have that. Move up a bit. There we go. Answer. And there we go. 22.02 degrees. I'll just round it to the nearest degree. Okay, solved. 22. Now what? What's the next thing logically you would find? The other angle. And I don't need trig for that. I can use my 180 rule. So angle C is 180 minus the other two angles, 30 plus 22. And I know it's not really 22, so I'm actually going to use, again, my calculator. And I'm not going to round that number. And I'm not going to put the calculator in the way. Stay up. Oh, and then I'm going to close it. Come on. Jeez. Okay, so 180 minus, open a bracket, 30 plus, but instead of typing 22, which costs me accuracy, just use the answer from what you had before. That's going to carry all the decimals. See, look, it's all the decimals. And again, I don't have to write all the decimals down. I'm going to round it to 128 degrees, but I'm not going to use 128 in my next calculation. In my next calculation, to find side C, C over the sine of C is equal to A over the sine of A. And again, I'll kind of skip steps here. I'll move the sine C up. So sine of the angle I just found times side A was, what was side A again? 8? Yeah. Side A was 8 over the sine of 30. And again, I'm not punching in 128. I'm punching in sine of my last answer times 8 divided by sine 30. And those of you who have calculators that don't have an answer button, that number 128 was on the screen and you just had to hit the sign button without rounding anybody. And this is the answer you should get, 12.6. Now I don't know how much you'd be off if you'd have just typed in 128, but it might be enough that if you were asked for the answer to the nearest tenth, you lose half a mark because you won't have 0.6. So there it is. So it's 12.6 centimeters. And there we go. That's the only way, let me shrink that a bit. That's the only way to solve this problem. There is one triangle possible from these three pieces of information. Any questions so far? I'll give you a sec to catch up to me. Okay, so the first one was not enough to have a triangle. Not enough of an A side. This one, the A side is longer than the B side. A is greater than B. So it gave me one solution. Check out the next one. The next one, we kind of know this already. There we go. So A is smaller than B, but it's bigger than half. We know half again because of this 30-degree angle. But we can check, right? Again, height would be B times sine of A, which is 4 times the sine of 30. And I don't need to punch this because I do know that the sine of 30 is a half. So it's 2. So A is bigger than the height, but it's smaller than the adjacent side B. What does that mean? It means that we have two triangles. And again, we have true triangles because A is less than H, but also, there we go, less than B. So we have two triangles, and here's why we have two triangles. I don't like that angle. I'm going to draw it again. Because starting at the 30-degree angle here at A, that side, that's 4, that side that's 3 could go this way, or it could go this way. I'm trying to draw this exactly the same, but this time it goes down that way. Do you see the logic on that? This line here could have swung to the left instead of the right, and it would still make a triangle. And I don't know which one it is. There's not enough information to tell me which one it is. So what do? I solve two different triangles. Yeah.
Why?
Because it wants me to solve the triangles. Now, here's the way I'm going to do this. I still like using A, B, and C, because if this is side B, then this is angle B. But over on the other picture, this is a totally different angle B. Now, they do have a relationship to one another, and we talked about that the other day when we did this as an activity. If I put these two pictures on top of each other, let's say I'll do this one in black, the big one here, but if instead of this line here going this way, I'll do this one in red, what if I'd have made it go this way? Now, notice the two triangles here are the black triangle and the red triangle. But I've also created another triangle that we're not going to really solve for, but I do know that it exists. It's this blue triangle. Now, what do we know about the blue triangle? It has two sides the same. That begins with the letter I. It's isosceles. And what do we know about the angles at the base of an isosceles triangle? They're the same. So if this is angle B right here, and I solve for it, well, then that's the same angle over here. But now, I'm going to call this angle here, I'm going to call this angle B primed. It looks like I'm saying B to the exponent 1, but I'm not. I'm saying primed. It's like an apostrophe. B primed is this angle in here. What is the relationship between angle B and angle B primed? Well, I'll give you a hint. They're along a straight line. They add to 180. The fancy word for that is? They're supplementary. So that is how I'm going to solve this. So this actually, oh man, we're solving two triangles in one problem. Yeah, but there's a shortcut for one of the angles. The relationship between this angle here and that angle there is that they're supplements of each other. So I just have to use a 180 subtraction. Okay, first of all, let's solve for angle B. Same way we did it in the last example. Sine of B over B equals sine of A over A. Let's plug in the numbers. The sine of B is equal to 4 times the sine of 30 over 3. And okay, let's punch buttons on that. Okay, let's move that up so I can see it again and go back. Calculator. Okay, so on. So 4 times the sine of 30, close brackets, divided by 3, and then inverse sine that answer is 41.8 degrees. So actually I don't really want the sign on that. So angle B is 41.8 degrees. Okay, keep in mind we're going to use that number later. But let's do the same things we did on the original picture. Let's now solve. We figured out angle B is 41.8. I'll use that purple again for the ones that I had to figure out. 41.8 degrees. And then that means that angle C, which is up here, 180 trick. Add the 30 that I started with the 41.8 that I just figured out. And again, I'm going to use my calculator for that so that I have all of the lovely decimals. So 180 minus, open a bracket, 30 plus my last answer, which was 41.8. And so that's 108.2. And then I have to find side C. And again, C over the sine of C is equal to A over the sine of A. Skipping a step there, sine of the angle I just figured out times side A. What was A again? A was, what was A again? 3. Divided by the sine of 30. And I'm going to punch buttons on that. So sine of the angle I just figured out, and again, those of you without an answer key, just hit the sign, assuming that 108 point whatever is still on your screen. And I can't see my calculation. There we go. Times 3 divided by the sine of 30. And this is a side, not an angle, so no inverse anything. So C is 5.7. Are we in centimeters? We're in centimeters. Okay, let me shrink that down. So we have solved the triangle on the left. We know everything there is to know about it. But we got to figure out everything there is to know about the triangle on the right. Now, I've already called this B prime because it's not B. I'm going to do the same thing up here. I'm going to call this angle up at the top here C primed because it's not actually angle C. It's the angle C in this version of the triangle. And I guess that means I'm going to call this little side here little c primed. Notice it's got to be way shorter than side C over here.
Wait, what are you calling it prime again?
Because I want to stick to the same letters because it is the same situation, it's the same givens. But they're obviously not the same length, right? Little c here is much shorter than little c over here. So I just use a prime rather than making up new letters and confusing myself. Okay, so back in time, over here, this is me solving the first triangle. There's the three things I got. This one here helps me find that. The relationship between these two things is, I'll write it down in words here, angle B is supplementary, are you okay if I abbreviate supplementary? To angle B primed. So, I'm going to use that fact. 180 minus 41.8 is equal to angle B primed. So, I'm going to use my calculator. Now, I don't have 41.8's decimals on my calculator anymore unless I put them in my memory. I could, if I really wanted to be accurate, I could take the time to just repunch that calculation. In fact, maybe I'll do that. Maybe I'll play hide and go seek with the calculator somewhere. Oh, that's frustrating. There we go. Stop moving. So 180 minus, oh, I guess I got to move it some more to see what the calculation was. We got angle B by going 4 times sine 30 divided by 3 and then inverse sining it. Here, I'll do it as a shortcut. Inverse sine of, open a bracket, 4 times the sine of 30, close the bracket for the 30, close the bracket for the numerator, divided by 3, close the bracket, equals, and there it is, 41.8. So 180 minus that answer is 138.2. So therefore, angle B primed is 138.2. Does that make sense? Yeah, it does, because take a look at the picture. This is a very obtuse angle, right? Because we had to shove this line like way to the left to make a triangle. So it makes sense that this is a very obtuse 130, 140 degree angle. Makes sense. Always kind of check as you're going, does my answers make sense? You'll catch your button punch errors that way if you do that. So, okay, so 138.2 is angle B. We can find angle C in the second triangle, which again I'm calling angle C primed, using the 180 trick. All three angles, even when one of them is really obtuse, still have to add up to 180 or you don't have a triangle. So there's the 30 degrees we were given for A, plus this 132 I just figured out. So go back to my calculator, which is making me cringe every time I try to bring it up. There we go. 180 minus, open a bracket, 30 plus the answer I just had, that 138 number. 11.8. And that kind of makes sense too. Again, take a look. What's C prime look like? Oh, it's very skinny, which makes sense. So it's only like 12 degrees. It's a skinny little angle up here. All right, let's keep on trucking. We still got to find side C primed. Side C primed over sine C primed is equal to A over sine A. I don't need primes on the A's because the A values are the same in both triangles. That's why I wouldn't bother doing that. So C primed is sine of that angle I just figured out, 11.8, times, what was A again? A was 3, all over the sine of 30. So C primed is, and okay, calculator, behave yourself when you come back this time. There we go. Sine of the answer I just had times 3 divide, whoops, no, delete, divided by sine 30 equals, and ooh, that's a tiny number. Are we expecting that? Let's have a look. Could side C primed really be that short? Well, yeah, because when the angle, or when the side that was 3 units long went this way, it created a big, long side C. But when the side that's 3 goes inward this way, it creates a tiny little side C. So yeah, that does make sense. So there we go. There is the work you have to do on an obtuse case, or sorry, ambiguous case question. Okay, so where did I lose you?
When you started to solve the really skinny triangle.
So when I'm solving the really skinny triangle, the relationship, see, the calculator doesn't know which triangle it's solving. So it just automatically assumes, oh, you must want this one. You don't want this skinny little thing. You want this one. So it gives me 41.8. But the relationship between this angle here and that angle there is that they're supplements of each other. So that's why I started off solving the second triangle by exploiting that fact. I took the 41.8 I got the first time I solved B, I subtracted it from 180, and there's my other angle B, which I call B primed. So that gave me this angle here, and then the 180 trick gives me this angle C, which again I'm calling the other angle C, so I called it C primed. So that was 11.8. And then I used the same method I found side C to find the other side C, which turned out to be this really skinny little 1.2. All right. All right, moving on. You have some to try now. That's it for the lesson. That's all the examples I wanted to get through today. So there's some for you to try here. I actually think maybe you should try the textbook questions first and maybe save these till later. So if you go take a look at the blog, I did one of those things where I kind of wanted to make sure my blog was ready for most of the week. So I've got Monday, Tuesday, Wednesday. Today's only Monday. So the questions I'm going to assign from the textbook are right here. Page 183, 4, 6, 8, 12. Just 5 questions. Okay? So that's what we're going to get you to work on for the rest of this class. Feel free to help each other out, make sketches. Make a sketch of, when you're doing question 4, make the sketch of the question, then look at your partner and go, did they get the same sketch as me? Right? Make sure, I don't mind you working together. And then tomorrow, for review, we'll do these questions here. And then we'll maybe do a couple more textbook questions. I've already assigned them, page 194. We'll do that tomorrow, kind of as a review day. And then that's it. Wednesday, we'll do one more kind of work practice day, and then we'll test Thursday. And that's it. Chapter 4 is over. It's not that much different than Chapter 3. Okay, I'm going to stop the video there.